You've seen it everywhere, right? Generative AI is changing our world. But there's this ghost in the machine, a weird tendency for AI to just confidently make things up. Now, these aren't just little quirks. They're called hallucinations, and they're the single biggest reason we can't fully trust AI. So in this explainer, we're going to pull back the curtain and see exactly how we're learning to measure, manage, and finally tame that ghost. So what exactly is an AI hallucination? Let's nail this down right now. It's simply this: assertions or claims that sound plausible but are verifiably incorrect. And that right there is the key to the whole problem. They sound plausible. They feel right, which makes them incredibly sneaky and dangerous. And that's where the real trouble starts. These plausible lies, they can just totally shatter our trust. It turns this incredibly powerful tool into something you just can't rely on. So for AI to really reach its potential, fixing this has become the absolute make or break challenge for the entire industry. Because this is such a huge deal, the hallucination rate has gone from being some weird bug to a crucial key performance indicator, a KPI. I mean, developers are now tracking this with the same intensity as they track speed or uptime. It's not just a flaw anymore. It's a fundamental measure of whether an AI is even worth using. You know, this new focus on tracking the problem brings us to the central idea, kind of the mantra for this whole explainer. If we can measure it, we can manage it. This one thought is what's turning hallucinations from this mysterious, fuzzy problem into a real engineering challenge that we can actually solve. So how do we actually measure it? Right before we can even think about fixing these errors, we have to be able to find them. This whole section is about how we take this vague concept and turn it into a hard number, something we can track and, most importantly, improve. And it turns out there are a bunch of different ways to hunt for these hallucinations, and each one has its own pros and cons. Think of it like a toolbox. You've got token similarity over on one end. It's super fast, basically free, but it misses a ton. See, it's got high precision, which means when it does flag something, it's usually right, but it has crazy low recall, meaning it's only finding a tiny fraction of the actual errors. Then on the other end, you have something like this advanced BERT checker. It has the best overall accuracy and it finds almost everything, but yeah, it's going to cost you more to run. There's no one perfect tool. It's all about picking the right one for the job. But what if we want to get even more sophisticated? Well, researchers developed this incredible method called HalluMeasure. Instead of just giving a simple yes or no on whether a response is bad, this thing acts more like a microscope. It gives us a really detailed, granular look at exactly where and how the AI messed up. So here's how that microscope actually works. First, HalluMeasure takes a big, complicated AI response and just decomposes it, breaking it down into individual, bite-sized claims. Then, it goes through each one and classifies it. Is this claim supported by facts? Does it contradict them? Is the info just absent? And finally, it gets super specific, pinpointing the exact type of error. Was it a wrong date, a misattributed quote? It's like a complete forensic analysis of the AI's output. Now, the secret sauce that makes HalluMeasure so good is this technique called chain of thought reasoning. And it's actually a pretty simple but brilliant idea. Instead of just asking the AI for an answer, you ask it to show its work by explaining its thinking step by step. Just that little tweak forces the AI to be more careful and deliberate, which makes it more accurate and way easier for us to see what it's doing. And you can see the impact right here. It's not just a theory, it works. Just by adding that show your work instruction, the accuracy of the detection model jumped. It might look like a small change on the chart, but that 2-point jump is a really tangible improvement in performance. Okay, so we can find the hallucinations. That's huge, but that's only half the battle. The really crucial next step is fixing them. And one of the most exciting new methods for this doesn't rely on a single super smart AI. Nope, it relies on a whole team of them, all working together. This whole teamwork approach is called agentic AI. The idea is actually pretty straightforward. Instead of one giant all-purpose AI trying to do everything, you create a team of smaller, specialized agents. Each one has a very specific job to do, and they collaborate to create a final response that is as factually solid as possible. And this is what that teamwork looks like in action. It's basically an AI assembly line for fact-checking. You have a front-end agent that writes the first draft, then a reviewer agent comes in and acts like an editor, flagging potential mistakes. A third agent refines it even more, maybe strengthening the disclaimers. And then finally, a KPI evaluator agent scores the finished product to see just how much better it got. So, how do these different AIs actually talk to each other? Well, they use a shared structured language. This lets them pass notes back and forth. But here's the cool part. They can include what's called whisper context. Think of it like a little private sticky note that one agent passes to the next, warning it about a potential problem. This makes sure that crucial context never gets lost as the response moves down the line. Now, to track how well this AI team is actually performing, researchers came up with a much smarter set of measurements. So instead of just asking, is it true, they measure things like factual claim density, basically how many verifiable facts is the AI even trying to state, or fictional disclaimer frequency, how often does it explicitly warn you that something is a myth or just pure speculation. It's a much more nuanced way to grade trustworthiness. All of these new measurements then get rolled up into one single number, the total hallucination score. Now, you don't need to worry about the math here. The core idea is simple. The score goes down when the AI makes fewer unsupported claims, and it also goes down when it adds helpful warnings and disclaimers. The goal? Get that score as low as you possibly can. So, does this whole AI teamwork thing actually work? Oh yeah, the results are just staggering. Look at this. After just the second agent did its review, the hallucination score plunged by over 800%. Then you add a third agent, and the reduction is nearly 2,800%. This just brilliantly shows the incredible compounding power of having AIs check each other's work. So what does all this mean for the big picture? Well, we are clearly on a path to building AI we can actually trust. And we're doing it by moving away from these vague promises of accuracy and toward quantifiable, measurable reliability. If there's one key thing to take away from all this, it's this. The problem of AI hallucination is no longer some spooky, unsolvable mystery. By developing these amazing tools to measure it with precision, we've turned it into a manageable engineering challenge. Reliability is becoming something we can actually design, build, and improve step by step. And this is a total game changer. It means we can now scientifically benchmark different AI models to see which ones are truly the most reliable. We can measure the exact impact of a change, like adding new data, to see if it actually cut down on hallucinations. We can finally treat trust with the same engineering discipline we apply to everything else. So this leaves us with a really fascinating final thought. We now have the tools, the metrics, and the strategies to measure, manage, and mitigate AI hallucinations with incredible precision. The question is no longer if we can build trustworthy AI, but how quickly we can do it. Are we actually witnessing the beginning of the end for the era of untrustworthy AI? It sure is starting to look that way.